first question being out of the scope question for the general knowledge. So how the ships, aircraft are earthed? Because you pointed out out of scope things as ships and aircraft, right?
Yeah, ship and aircraft, of course, because normally when you look at these type of things, they are working with the body as the earthing system. So that earthing means, as you said, when you look at even a TT earthing arrangement, what we say as a earthing, because we connect to the earthing system, but the main requirement is you need to have a basically circulating path. So that, for example, when I look at the normal supply system, so even if you have a source with a certain type of the load, what you want to have is even here, if you have a connection like that, this is what we need. So that we are creating earthing system because we know that the earth is everywhere, and because of that we are taking earth as our reference point. Other than that, you don't need a earthing system, or you don't need the earth, because if you can create this type of a closed loop, so that even if there is a certain abnormal current, that will go through the closed loop, so that you can detect it and you can isolate the system if there is anything. Now in here you can see no current go to the earthing, the grounding system, or what we call as a IG, grounding current is 0. So if you have this type of thing, but as I said, if you have a TT earthing arrangement, when you have something like that, so in that case, you will see current goes to the ground. So in that case, you need to have this is where you are looking at your RG value, have a lower earth electrode resistance, or all of them are basically talking about, because that can create a ground potential rise. Otherwise, now in here, you don't care about the earth electrode resistance value. Even a TN system, that's why you don't care about your earth electrode value. Other than the lightning protection system, lightning protection standard says that you need to maintain less than 10 ohms of earth electrode resistance value. Other than that, for the protection requirement, you are not caring about the earth electrode resistance value. Even if you don't want to measure the earth electrode resistance value for a TN system, for the sake of the safety, other than the lightning protection, because there will not be any ground current going to the grounding system. So that all these aircraft, everything is the design based on this criteria. So that they create a closed loop, so that with the protective devices, so that if there is any abnormal current, those protective devices will take care. You don't want to send any current to the earth. That is the criteria in all those locations.
Thank you very much for the long explanation. Yeah, it's very clear. Next question is, dear sir, in a high-rise building, windows equipotential bonding is connected to the lightning protection down conductor, within brackets run inside column, but there is no connection between flow and the down conductor, not even a rebar connection. Is this okay? You got to.
As I said, if you are doing this one, you have to do carefully, because when you look at this rebar connection, anyway, if you are using the rebar down conductor, or if you are using a down conductor to your columns, anyway they are connected. So that normally your rebars will be all connected together. So that even as I showed you here, so that for example, now you can see if you have a down conductor, now in here, you can see there can be conductors going up like that from the foundation, so that ultimately all of them are connected together. Here you can see when you look at your flow, so all of them are connected together. So that likewise, now the concept is this type of a three-dimensional earthing arrangement where all the flows are connected together, foundation is connected together, all the equipments are connected together, so that even when there is a lighting the discharge, they will travel and everything will be in the same potential. So keep in mind the damages are happening, always the damages are happening when you have a potential difference. So if you are keeping everything in the same potential, damages are not happening. So that's why the standards are recommending with this type of equipotential bonding with the surge protective devices, because the surge protection is also mandatory. So that just connecting them is not enough, but also because you have to maintain your services in the same potential as well. To maintain that one, you need to have the surge protective devices. With that, then connect everything. Okay, you don't want to the afraid of connecting them. Connect all these steel frames, steel bars, everything, and even the foundation, everything. So and create a equipotential bonding everywhere.
Okay. Okay. I hope it is clear. Next question is, what is the minimum distance between transformer neutral earth and building earth?
That will depend on, as I said, what type of earthing arrangement you have, whether you have a TT earthing arrangement or a PN earthing arrangement. So if it is a TT earthing arrangement, you need to have a separate transformer neutral earth. Okay? So to the building earth or your installation there. So in that case, normally that will depend on your soil resistivity. As a thumb rule, normally if you can maintain something like more than 20 meter separation, you can achieve the electrically separated two earth. So that is the requirement. So otherwise what will happen is, even though the maintain two earth, so they can create something like a connected type of things, where ultimately what will happen is you try to reduce your earth fall current, and then you do all your calculation assuming that okay, there will be a reduced earth fall current, but the earth fall current will be a very high value. Okay, so because now, for example, as I said, why do you want to go for TT earthing arrangement? That first you have to decide. Otherwise, okay, if you are taking a connection from distribution arrangement only, you have to go for a TT arrangement. Otherwise, okay, you don't want to worry about the separation, because obviously, so having a same earthing will give a better protection.
Okay. Right. I hope it is clear for the question. Next question is, sir, can we use flexible cords for the permanent wiring in a building?
Flexible cords. Flexible cords.
Can the question raiser clarify it? What do you mean by cords?
Well, it's a cords or cords. I didn't get it.
I didn't flexible cord. That means flexible wires are there, no? That was he's asking.
Spelling is CODES, codes.
Cords. Yeah, because the regulation does not restrict whether it is a flexible or whether it is the solid door, multi-span or whatever. All of them are allowed. Only thing is you have to maintain the required mechanical protection, so that if you are maintaining whatever the flexible cord, if they have required mechanical protection as well as the required insulation level, then the standard does not restrict to, because that's why these codes and everything is there. But you can use for any application, as I know, because if there is anything other than that, if there is any participants, if they want to give any idea, as I know, there is no restriction, because that's why the regulation gives us all different type of conductor types. So where you can use depending on the requirement. Only thing is you have to make sure that you are providing the necessary mechanical protection. If you are providing necessary mechanical protection, whatever the cable type, whether it is flexible or whether it is the solid or multi-span or whatever, this doesn't matter.
Right. Thank you. Next question is it necessary to use Rcdn breaker switches in sub-distribution boards, or there is a maximum length to use those in a sub-distribution board?
Now, when you look at the protection requirement, as I said, because we are looking at the overload protection and the short circuit protection and the earth fall protection. So when you look at all these things, so that in the distribution board level, you have to decide, the designer should decide how to provide these different type of protection. But the residual current protection is mandatory, so that it says that, okay, even if you have a one residual current device protection, which will take care all the entire installation, that is also sufficient as per the regulation. So the regulation says that even in the end, the equipment or end level, if there is a earth fall, if that is detected by the main switchboard, that is fine, because you isolate the system, but your reliability reduces. So that it's a designer's requirement to decide what level and what coordination should be there. But if you look at the overcurrent protection, you have to keep in mind, very clearly standard says us, you have to have an overcurrent protection every origin point of the circuit. So that overcurrent protection is mandatory at the every origin of, but there are certain omissions are there. But general rule is overcurrent protection is mandatory at the every origin. But RCD protection or the residual current protection is mandatory for the installation, but it's up to the designer to decide what level or the distribution board they have to use the RCD protection. So if the main protective device protect at the end, the most extreme end of the distribution system, then that is also sufficient. But keep in mind, in that case, if there is a earth fall happen at that point, entire building or entire installation will be disturbed. So that it's up to the designer to decide what level he has to put these RCD. But the overcurrent protection, it's a mandatory to have overcurrent protection every origin point.
Okay, thank you very much. Next question is, dear sir, for lightning arrestor system for a high-rise building, will there be a single earth connected to the main earth, or cannot we use separate earth pits from foundation?
Normally, when you look at the IEC 62305 standard, that talks about three different options of earthing arrangement. One is every down conductor you can have individual earth electrodes. So that is, for example, when you look at these down conductors, you can have earth electrodes like that, individual down conductor. You can put earth electrode, but you can see it's, when you look at these, the earth electrode, now it is connected all together. So where you can have a earth pit like that, or even you can have the ring earthing system like that, and connected together, so that that option is also available. And also you can just use the foundation as it is, and the whatever the ring earthing system can be used around the building to maintain the state potential and the touch potential. Like that, all these options are there. It's up to the designer to decide what is the most suitable arrangement for that the particular location. So those three options are available. One is the individual earth electrodes, or the ring earthing system, or foundation earthing system.
Okay, thank you very much. Next question is this regarding the RCD sensitivity. When multiple level of distribution boards are present, 30 milliamperes should at the final distribution board. Question is clear? When
Well,
multiple level of distribution boards are present, I think whether he's asking whether 30 MA should be at the final distribution board.
yeah, 30 ampere is mandatory for the final distribution board, where you cannot have more than that, especially for the highly sensitive the equipment and induced equipment. But keep in mind, when you are putting this RCD in a cascaded arrangement, cascaded arrangement. Now, for example, if you have a several RCDs, this is again one of the mistakes most of the people do. Let's say you have a RCD1 and RCD2, and if you put a RCD3 like that, now this is your downstream currents are flowing in this way. Now, let's say people think that, okay, I'll put 30 milliampere here, and then I'll put 100 milliampere here, and I'll put, let's say, 300 milliampere here. So is sufficient? Is it sufficient? So if I put the RCDs like that, so will it give the protection coordination?
Okay. Yeah.
So that will not happen, because now, for example, if you have a certain earth fault here, maybe this earth fault current can be 300 milliampere. That is your earth fault current. Now you can see, if you have a 300 milliampere, this RCD will also activate, this RCD will also activate, maybe this RCD will also activate. So this is where you are getting the nuisance traffic. So that people think that if you put the RCDs like that, that will solve all the problems. But that will not happen. So that's why normally there are the general RCD and type S RCD. So that if you are using the general RCD here, you have to use a type S RCD here, where you cannot use the RCD there. You have to go for a EFR or ELR with a delay. So that then only, because then only you are providing with the coordination with the time delay. Because you have to keep in mind, this 30 milliampere does not mean that your fault current is 30 milliampere. So the fault current can be more than that. So if it is more than that, so the downstream fault, sometimes your upstream, the RCD can trip off. So these are happening in the hotel building and many locations. People put RCDs in cascaded arrangement in the sub-distribution board, final distribution board, like that. So all of them are general type RCD. So that people think that by putting 100 this type of the sensitivity will solve all the problems. That will not happen. So that because of that, you have to have a coordinated the residual current devices. Otherwise, by coordinated does not mean that, okay, this is coordination. This is not coordination. You have to coordinate with the fault current.
Okay. Thank you very much. Right. Time to time, your voice was breaking. Maybe connectivity issue. I hope the question raiser got the core of the answer. Next question is, what is the minimum distance between the generator earth with transformer earth and surge system down conductor?
As I said, everything will depend on your earthing arrangement. So, for example, if you are designing a TT arrangement, your transformer neutral earth, you have to have a separator, and the generator, you have to have a generator neutral point separator. But sometimes, okay, some location I have seen transformer you are maintaining separator, but the generator body earth also you go and connect to the normal electrical installation there, so that ultimately when the generator runs as a TN system, but the transformer runs as a TT system. But that's why I said, if you are designing a TT system, you have to have a separator for the transformer neutral, generator, the earth, and even there is no the problem with connecting the generator neutral and the transformer neutral together, because if they are not running synchronous manner, so if the transformer is not available, so the supply is not available, then only generator runs. But electrical installation, as I said, if you are maintaining separate for the electrical installation, that they should be separated at least something like a 20 meter separation. There is a thumb rule that can change from location to location. As a thumb rule, generally, you better to maintain at least 20 meter separation from those the neutral point to the installation there. As I said, the concept is okay within the installation. If it is a even if you have a lightning arrestor should be connected to the building earthing system. You cannot maintain separate earth for the lightning arrestor. Everything should be connected to the equipotential bonding, so that you have a equipotential bonding bar that is connecting all your electrical and all those things. And then you have your earthing system. There can be multiple layers. So including your lightning arrestor. So the lightning arrestor should also be connected to this multiple. You can use the multiple layers to reduce the electrode resistance. And also your equipotential bonding should also be connected to the same earth. Now you can see it's a common earthing. So it's a common earthing. Within the installation, you cannot maintain separated. But for the transformer, now as I said, your Y connection can have a separator, but all these are separated. This source is separated from the building earth, but lightning arrestor and all the instrumentation, telecommunication, everything should be connected to the same working system.
Okay.
Dr. Asanga, coming back to your point, Dr. Lalit, give me one chance. If you are going for equipotential earthing systems by connecting all the lighting arresters, measuring equipment, and all those power earthing systems, but as per the IEEE regulation, there must be some what is called resistance value, maybe one below the 1 ohm. If the resistance value is 1 ohm below, then we can go for a equipotential bonding systems. Is that correct?
No, this 1 ohm, I cannot find out where did you get this from. But when you look at the IEC 62305, 62305, they specify below 10 ohms. So that is also recommended to have a below 10 ohms, but there is no strict rule for the earth electrode resistance. So basically, because when you look at this the earthing system, what we are telling is you have to connect them together, but also you need to have the surge protected devices connecting to this system. So if you combine them together, then that's fine. As I said, because I didn't get the value like 1 ohm in a regulation, but the IEC 62305 says that is the lighting protection standard. Lighting protection standard recommends to have, it's a recommends to have below 10 ohms. What they are telling me is better to have a lower value, but at least maintain below 10 ohms.
Why I'm asking, doctor, because if I communicate with the SLT people doesn't allow to connect that they are to our system, equipotential one. They only use the separator.
That's basically because most of them are unaware about this one. Even last week I did the workshop for SLT people, all the SLT engineers and the other people, and also even that one they also highlighted the same thing, because it was not communicated by anybody, and even the members of anybody. That is the reason why they are imposing these type of things. But as I said, these are new the change regulation so that now what they are telling is okay, don't make separators.
Ravi, we have SLT engineers in the forum. If
Yeah,
you want
that's it. Yes.
are you okay, Ravi?
Okay. That's what I give my views. That's
Okay. Thank you. Thank you, Dr. Asanka. And yeah.
Seminars are needed where we want to educate the people. Otherwise, the people still keep all type of the concepts in their mind, and sometimes they are also got those things from their superiors or the senior engineers. They may refer older versions. In the older version, of course, they were using these the separators, those type of things were there in the older regulation. But now the people the understood that okay, these are not the best way of giving the earthing system, so that better to go with the equipotential bonding in terms of the EMC, in terms of the power quality, in terms of the safety. Now the best practice is the equipotential bonding.
Dr. Asanka, I am Gunatunga from SLT. Actually, you have did a marvelous presentation those days for the SLT people, but I was raised this what you have mentioned about the equipotential bonding at the telecommunication earth and the electrical earth in the customer's house. But what we are experiencing is when we are going to connect those things to the electrical earth, sometimes the customers don't like to connect the telecommunication earth to the electricity earth. Sometimes from the CB side also they don't like to connect the telecommunication earth to the electrical earth, and the other way around also. So this is actually some sort of a difficult situation sometimes. So I think CB people and the telecom people should get together and solve this problem.
Yeah, exactly. Now, when you say that, okay, that they don't like, okay, it's a they don't like, but it's basically because of their misconcept and their unawareness of these techniques. That is the main reason why they are, for example, now you are the best person to advise the customer, because the customers are the ordinary people. They don't know anything about this electrical thing. They are ordinary customers. So that you are the expert, you are the people where you want to get together and then advise the people. So this is the new concept, and even you can develop your institutional kind of the framework or kind of the guidance notes to all the people, saying that this is the method you have to the implement when you are implementing these type of things. Likewise, you have to get together. Even IET can initiate some kind of the forum where we can the publish certain type of white paper or certain type of guidance notes for the telecom people, CB people, those type of things, and making aware what are these new concepts and new requirements, so that then everybody will follow this one in the same manner. So that, as I said, if the people may say, I don't want, but without knowing what is the background or what is the theory behind this one. So that's why these type of awareness are needed, where then the people will get aware about what are the requirements.
Thank you, Dr. Asanka, for the suggestion. Since I have both SLT and CEP engineers in my committee and also in the IET membership, we will consider this request, and I will discuss this matter in the next committee meeting and try to do something for the industry that would be better, rather than pulling to their own sides, right? I mean,
I think Dr. Lalit, that proposal is very good for the IET.
Yeah. And what Gunatung, I think, from SLT, thanks for coming out and expressing your views, and we will take this
and also Dr. Lalit, now we are little by little moving towards to the fiber to the home by, I mean that abandoning that legacy PSTN network, but in the legacy PSTN network, we require some sort of a thing. But in the FTTH connections, actually, I mean that we need not require any type of earthing system or something actually in the virtual way, but that what you call the drop wire or the FTTH drop wire, it also contains two numbers of small what you call iron membranes to giving the mechanical protection to the drop wire. And we have also seen that some sort of lightning damages has happened to the equipment through these small conductors as well, but very little. But there are no way to install a earth conductor to the fiber connection at the premises. So virtually there is no harm, I think, without any earth electrode in the FTTH connection. So I think by changing the type of the drop wire, then we can protect all the communication system separate from the light.
But didn't you answer? I think some views I can give against the fiber optic connections. I think Mr. Engineer Gudlik may be there. My name is Engineer Ravi Rupa Singh. I have been experienced that even my home also I am getting many trouble due to lightning. The unit and the Wi-Fi unit has all the unit has been gone many times due to lightning. But I asked from the SLT any solution for that.
No,
they say nothing.
Actually, Ravi, it is not coming through the fiber network. It is because of the power network, right? There may be, I mean, that some sort of power fluctuation may very sensitive to the
no. Actually, I got the first answer like this. Then when the lightning is there, I disconnect all the things and keep the fiber optic as it is. In that case, also you got.
No, it can be happen, but you know that the fiber theory, according to the fiber theory, there cannot be any electrical signals coming through the fiber optic cable. So it may be due to the what you call inductance. So I mean that due to the high currents or something, may be the inductance of the things. So I think so. Otherwise, there is no way to come those lightning to the equipment.
Maybe, Ravi, do you have any self-protective devices in your house?
I have a surge protected device for my power systems. I think many cases I experienced that my what is called data connection has been lost. Even CCTV, what is called SLT connection lost. So because I have a fiber connections.
Yeah, most of the cases.
Then I got the answer from the SLT saying that it's due to power fluctuation and the surges coming from power line. Then what I did was I disconnect power line and disconnect the power supply to the unit, and I keep the SLT, that means the fiber optic line as it is. Then also I experienced that it has been gone. Many cases.
Maybe there can be certain influences for you because you have a copper cable from the after the fiber router. From that one to the other location, you have certain copper cables running for even for your telephone system. Inside the house is copper cable. So there can be certain influence or certain induced voltage to the copper cable, which can travel back and damage your equipment. So that there can be a situation like that, even if you disconnect, because obviously, as the previous person, the SLT person said, because there is no way of coming the surges coming in through the fiber optic. That is obvious, but there can be certain surges which are initiated within your building or within your premises due to many reasons. There can be a connection or can be a certain surges happen to a closer location or closer the building or anywhere. which can create that type of the voltage coming into your system through your earthing system, which
But my
I
unit
guess
has been installed in a separately, not nearby any power line.
but for example, if you have even a telephone cable can induce due to those maybe I'm just telling the possibilities. There can be possibilities, but normally you will not get any surges through the fiber optic. Surges can enter to your building through your earthing system and to the other type of the means like if you have any other services, through those services they can enter to your building and then damage your equipment.
okay. Thank you.
Separate
Thank you, Ravi and Mr. Gunatunga. I think there is a provision for us to, discuss this little more in detail. I think I will facilitate this as IET chairman. Between SLT and CB, we can have some resources, and also we can invite Dr. Asanka also to help us. So we will discuss this in detail, and if there's a need, we can publish a white paper on this. So this will be good for the industry. So thank you very much for that.
Thank you very much, Mr. Ali.
Yeah, clarification. Thank you, Mr. Gunatunga, and let me take the next question. Is it needed to install a 100 milliamp RCD at the meter panel if the service cable of a domestic supply 30 ampere laid underground from meter panel to MDB? Question is clear?
Yes. Normally, we are not installing the RCD there because we are assuming that when you look at the meter point is your starting point of your installation. So that generally what you do is traditional practice is where you are taking the insulated cable up to the distribution board where you are providing only the overcurrent protection. For example, if there is anything happen, so that will be in between the cable. In between the cable is a short circuit situation which is taken care by the overcurrent device. For example,
No, doctor. No, doctor. Right now.
Yeah. Okay, Ravi, go ahead.
Right now, CB and LECO is asking the same requirement because we are going for a certification.
That's what I am explaining. So that that is the normal practice. Okay. But when you are having a underground cable with a normally armored cable, so there can be a situation where there can be insulation failure. Due to that, the live wire insulation failure, there can be earth leakages. So that generally in the utility system, you don't have any device to detect that type of insulation failure, especially with the armored cable. So when you have the armored cable, then obviously there can be, if there is an insulation failure, there can be earth fault. Earth fault will not be detected by the utility because utility they don't continue the earth wire. So it's a low impedance, high impedance earth fault. So that's why now the utilities are asking if you are having that type of underground cable, better to put the RCD there. In any case, if there is a earth fault situation, then that will be taken care by that RCD. Because now, as I said, now in the traditional system, when you have the two main cable or for insulated cable, then only possibility is because you are not running a cable in that main wire. So that even insulation failure, so if there is a single insulation failure, nothing will happen because you have a mechanical protection, you have a double insulated cable, and you have a conduit as well, nothing will happen. So that, but if you have a two insulation failure, like the live wire failure, then that will be detected as a overcurrent the fault and by the circuit breaker at the meter cubicle. But in this case, now you are using the armored cable for whatever way, where even a single insulation failure will act as a earth fault situation, where we don't have any device to detect that earth fault. But in the other cable, now without underground, if you are using normal 4-core cable with inside the conduit, even a single insulation failure, nothing will happen, because that earth fault will not do anything, because you don't have the outer cover, you don't have a earthing connection, so that will be there as a sustained earth fault, but it's not a earth fault. You have an insulation failure, but you have a double insulation and the conduit as well, that is there, so that if there is two insulation failure, then that will be detected. But that new requirement is there for the underground cables.
Dr. Asanka, what type of sensitivity you will recommend for that meter cubical RCCB?
So as I said, now you have to decide your coordination, so that it's not only the RCD. Sometimes you may need a earth fault related with the delay as well, so that if your building is very complicated, where you have a different levels of a distribution board, you are using the RCD at the end level, like a normal RCD general type. Then the next level you may use the type S RCD. Next level you may use your main distribution board. You may use EFR, and the main cable also you may need to use a EFR with a certain time delay, because this coordination should be there. Otherwise, even for the end level earth fault, sometimes there can be trip-off from your meter part. So that coordination should be done. It's not just blindly put whatever the RCD from the market and put it there, but at least you need to have a type S RCD, because since you have another RCD inside the building, inside your home, so this RCD should be at least type S or with the delay type EFR.
Okay. Yeah, I think it's clear. Thank you.
Dr. Alit, I have another question related to that question. Dr. Asanga, actually, I argue with the CV, that's what I'm asking. Some cases, if I draw the underground cable, armored cable, your point is okay. But some occasions, we experience that we don't want to lay the armored cable. We can draw the cable throughout the wall with the conduit pipe and the concrete and everything. Because there's no any underground one, we draw the cable throughout the along with the wall. Then I advise you can use the copper PVC cable, and you can go up to what is called a meter in the wall front side. In that case also they are asking the RCCB CB.
In that case, I don't see there is a requirement. For example, if you are giving a mechanical protection for your cable, for example, it can be PVC cable with let's say the PVC conduit, so that you are giving the mechanical protection as well, so that if it is not going to the underground, then as I said, you don't need that the RCD, because in that case you have to keep in mind, because there is no point of asking RCD, because even if there is a earth fault will not be detected.
So that is the point I argue with them, but the engineer says this is our regulation. You have to put the RCCB. Without that, we are not giving the supply. Your report is not accepted.
There are a lot of myths as well. Very recently, I will tell you a story. I went to one of the bigger multi-story building just to check where the client asked me to come and check that building. And in that one, they have a dedicated transformer, and it's in the Colombo city, because I know that one of my student is there as an electrical engineer. And I went there, and there was the people who are in the site said that, okay, the CB people came and put two different earths. I said it cannot be, because as I know that they are not putting two different earths, and it should be a single earth kind of things, even for the body, and the neutral earth should be the common earth. But they said, no, see, they have put two different earths. And then I called the people called the ES, and the ES confirmed that okay, yes, they have put the two different earth. But I called the engineer and checked whether are you using this type of arrangement. He said, no, sir, we are not using. I already asked these people to put the common earthing, don't use different earthing. Maybe because this is a new ES came from somewhere in the distribution region, and he will use something else. I will ask him to correct it. We have a situation like that. So fortunately, I told the Colombo City engineer, and then he said that he confirmed that that is not happening. Like that, sometimes there are certain communication. That's why his IET, IESL, those engineers should put more and more this awareness and more and more. So then we can educate people. I hope I answers the question. Dr. Lalit, I think you are unmuted. Any other question?
Can you hear me?
Yes, sir.
Okay, right. So next question is, what is the average leakage current of LED lights? And is there any sum of leakage current percentage leakage current that can be connected to any RCD rated residual current? Two questions. What is the average leakage current of LED lights? And then,
yeah. So actually, when you look at this LED, the leakage currents are coming from EMC filter. So that all these LEDs, so the now new LEDs, they have a EMC filter. So this EMC filter will create certain type of leakage current, but those are high frequency. Now, what we have to do is we have to give a path that for this high frequency current to go to the source. So sometimes, as I said, because when you aggregate those the high frequency component, that will be detected as a RCD as a leakage current, total leakage current. So that's why when you look at these type of high frequency, the situation of high frequency or the harmonic rich environment, there are different type of RCDs. Like for example, the type B RCD, that will basically handle with the high frequency component. And also there are certain manufacturers who are coming up with the RCD with harmonic filters, where they will eliminate this harmonic high frequency component and only look at the low frequency component, so that those nuisance trippings will not happen if you are using correct type of RCD. But if you go with the normal RCD, like normal AC or sinusoidal waveform RCD, that they may give nuisance tripping with this LED the leakage current due to this harmonic. So that will not I cannot say a value, because that will depend on different manufacturer and their driver circuit. Some manufacturers, they handle depending on the PWM signal or whatever the switching the frequency, they handle the harmonic. So there are some locality the drivers as well, which can create a higher leakage currents as well. So that can vary depending on the type of the driver. So that because of that, I cannot give a exact value. Okay, this is the typical leakage value. That will depend on the driver circuit.
Okay. Yeah. So you answered both questions. Thank you. And next question is, what is the average leakage current? Sorry, it is the, yeah, it is the question I asked. What is the minimum separation distance between transformer equipment earth and winding neutral earth in a Mblv substation?
as I said, okay, there is no such requirement because you have to, when you look at this again, it's a, I have to explain it a little detail because of the time limitation. I'm not going to, I'm advising you to, in the IET wiring regulation, there is an appendix for the voltage disturbances. So in there, these are different type of earthing arrangement for Mblv systems, like with the substation, whether you have a transformer body earth separate and the neutral earth separate, and then combine them together, combining with the impedance. Likewise, okay, all those options, what are the earthing requirement and what type of insulation requirements are there is in the separate appendix of the IET wiring regulation under the voltage disturbances. Please refer that one. Even some of the ietsl the seminar, I explained that one. Unfortunately, I have not put a slide in here, but the go for it, or otherwise I refer one of my ietsl earthing seminar, which is in the website or which is in the YouTube, so that you can get an understanding about what are those requirements.
Okay. Yeah, with the interest of time, I know you have a long answer, but we'll cut short it. I think you got the person who raised the question got the crux of the answer. Next question is, can you briefly explain how to size AFDD?
Again,
long answer.
I think, yeah, it will take some time. Actually, I didn't go through those who are having those questions. He can contact me. I will explain how to do that one, because otherwise it will be halfway bit kind of thing, so that you will not get the exact idea. So if I quickly go through it, so that because there is a certain requirement where we have to look at. Those who are interested, you have my contact details. Either you can drop me an email or you can contact me through the mobile. I will explain.
Yeah. We will. Is it okay to share your email address, right, Dr. Sanka?
Yeah. It's in the slide also.
Yeah. With the recording, we will share your email address, so those who have more questions can raise with Dr. Sanka directly. I will get the next question. It is observing that most of time we can observe that there is voltage difference more than allowable amount between neutral and the earth. Hence, some three-phase equipment like solar inverters cannot operate properly and there are damages. How it is arrested in the new regulation?
As I said, because obviously one of the problem with the TT system is where you have a separate neutral earth and then you have a neutral conductor. Especially in the unbalanced situation, there will be a large current flowing through the neutral conductor, creating obviously we know that due to the, if you have a even situation like that, now you are maintaining voltage at 0 here, but due to the current flow, so and the resistance of the neutral conductor, there will be a large voltage drop or voltage increase at the end equipment. This is the situation. So there you will face this situation in the TT system. So the best thing is where you can, if you can do the balancing and then reduce this neutral current, where you can reduce the neutral voltage as much as possible. So because in the TT system, if it is a TN system, the easiest thing is where you can erase this point. If you erase this point, then obviously here the voltage is 0. You can maintain the neutral point voltage at a 0 point, but in the TT system, this is not allowed because you cannot have the different type of neutral point earthing other than the utility earthing. So this is inherent problem with the TT. Unfortunately, we adopted it, as I said, because the TT is not a very good earthing arrangement, so that there are a lot of problems. This is one of the problems. But in the TN system, you can easily avoid this problem by earthing the neutral point at your distribution boards.
Okay.
Dr. Asanka, I am Gunatunga, the person who raised that question, because I have observed that one of our inverters were damaged due to this situation, and it was due to the phase unbalancing situation in the CB side. So, is there any is there any device to arrest this situation? Is there any device to?
Because normally when you look at these, the voltages are normally when you look at the voltage disturbances, we categorize them into the transient voltage disturbances, which are taken care by the surge protective devices. But these are temporary over voltage or temporary under voltage situations where that should be corrected by the utility itself. Because in the inducer, at the moment, other than putting a voltage regulator or the voltage stabilizer and the maintaining it like that, it will be very costly when you look at the large capacities. It will be very costly. The best way is to request the CB or the LECO to do the phase balancing and then do whatever the mitigatory action for that particular location. Other than that, in the inducer level, I don't think there are equipment, but they are very costly. For example, you can put your separate the voltage regulator so that even isolation transformer within your premises and take the supply with the isolation transformer with the earthing connection. So that type of things can be implemented, but it will be very costly.
Okay. Thank you. Thank you very much.
Thank you, Mr. Gunatunga and Dr. Asanka. Next question is a tricky question. It's easy and time saving if we have our own codes in Sri Lanka rather than following UK-based code IET. Any update about local Sri Lankan code in future? You want to comment?
Yeah, now, normally, most of the countries, what they have done is they took the IET or BS 7671 as their the reference code, and then they implemented the same thing as their own standard. For example, even when you go to India, Thailand, Singapore, Hong Kong, many countries in this region, what they have done is when you go to their the standard, they have their own standard, but it's 1-to-1 BS 7671. Similar things are there even in Sri Lanka, because when you look at the IEC 62305 lightning protection standard, we have our own SLS 1473 standard. So that is SLS 1473 standard is a Sri Lankan lightning protection standard, which refer 1-to-1 IET IEC 62305. So that it's basically, but it's going as our standard. Even when you look at the Singaporean standard, they use the BS 7671, but they have amendment several things to suit it their environmental condition. For example, even though the TNC is defined in the IET Wiring Regulation, they basically banned the TNC installation in Singapore. Likewise, they have adapted in their local things, so that it's up to the local standard institute to take that and go forward. So but at the moment we are following it as it is. But as I know, there are no any discussion to even to have there was a discussion in the previously long time back to have our own standard, but most of the senior engineers and the senior professors, the idea was to keep it as it is. Okay, since we have a very comprehensive standard, okay, why can't we go for that one or use the same thing as it is? So there can be pros and cons in that one, but even IT can discuss whether to go or propose our own one. But the feeling is this IET wiring regulation is very comprehensive one. But there are certain things where we can change to adapt or change to suit with our requirement, our local requirement. So as I said, if you are going ahead, my feeling is, my suggestion is, okay, we take it and do certain necessary amendment to suit with our local conditions, and then we can come up with our own standard. Okay, so even IET can take a leadership.
Yeah. Thank you, Dr. Sankar. Yeah, we will consider these things because these are the kind of revisions or amendments we can do, which will be good for the country. So we have that responsibility, I guess, as IET, because as I said at the outset, it was IEE, Institute of Electrical Engineers, so we have a big responsibility to look after these matters. Next question is, what methods can be followed in precast buildings equipotential bonding? Do we need to connect all building parts together, such as floors, walls, windows, doors, etc.?
Yes, as per the IET wiring regulation, all the metallic parts should be, okay, non-current carrying, all metallic parts should be connected to the equipotential bonding. So there are no matter whether it is a precast or whether it is a normal construction, everything should be connected together. So that you have to find out a way to connect them. Now, for example, when you are installing your precast for these windows and doors, there can be certain cable connection to the equipotential bonding, or even some location you can run equipotential earth bar around the building, or where you can connect all these things to that equipotential bonding bar. So here you have to keep in mind, when we say equipotential bonding bar, that does not mean that it's a very small the copper connector like that. Even it can be a the bonding bar running all around the building, and you can connect all these metal parts to that bonding bar, and then connect to the earthing system. Likewise, because as I said, as per the standard, we have to connect them to the equipotential bonding.
Okay, right. Next question is, if we use TN earthing system, it will generate high fault current in line to earth fault. Are RCD still used for TN earthing system?
Yeah, it doesn't matter, because RCD, what it does is, if the fault current exceed more than certain value, so that will trip off. But is anyway disconnect the circuit. So, but depending on your fault current, you have to decide. Because RCDs are generally we are using at the end equipment or end the level. So where generally your fault currents are also the lower because of the high impedances in the end level. When you calculate the fault current at the end equipment or end level, they are also very generally low, so that RCD can handle it without any problem. Because RCD, for example, if it is 60 ampere RCD, and if you are the short term, because the RCD will give you what is the short term breaking current. So if it is within that breaking current, you can handle it. But there are in the front end or your upstream, there can be very high fault current. In that case, in order to handle that one, you can use either co-balance transformer or the certain CTs with the EFR for those type of location. So it doesn't matter. So you don't want to worry about your fault current. So only thing is, you have to size your the cables to handle that fault current. And if the protected device can detect that fault current, then that is it. Okay. No matter, because there is no requirement to have a lower fault current, because what you want to do is you want to identify the fault. If you have a higher fault current, identification is very easy.
Okay. Okay, understood. Next question is, what is the best practice for the load diversification?
Load diversification. I'm not sure what he is asking, Normally, the requirement is if you have a single phase loads, you have to distribute it such a way that it will finally create a balanced three-phase system, so that now when you look at most of the cases, you have to segregate most sensitive equipment in a separately and the disturbing signal separately likewise. So those type of things. But I'm not sure what is this asking about.
Dr. 𝐸𝐺𝐬𝐵, yeah, Dr. 𝐸𝐺𝐬𝐵, actually I focused on that means it is the rated diversification factor like case or something like that.
Right. So when you look at the diversity factor and the utilization factor, so again what the standard says is it's up to the designer, so that there is no any the guideline or anything given, because that will depend on the that particular installation. So that it's the designer's requirement to evaluate the operating pattern and the type of the operation and how the user is going to operate this equipment, and decide the proper diversity factor and the utilization factor. That's why when you look at even the 16th edition and the previous version, there was a certain diversity factor tables were given in the IET wiring regulation, but now in the new regulation, all of them were dropped, because saying that because it's a responsibility of the designer or the electrical engineer to decide appropriate diversity factor.
Okay, understand. Next question is, what is the best, is there any other good reference to be familiar with wiring regulations in addition to BS 7671?
There are a number of books. When you go to internet and find out, there's IET, even there are a lot of guideline notes. So when you get these guideline notes, even that set of guideline notes explaining that, because the IET wiring regulation is, as I said, like a Bible, where it refers different things in the different chapter. If you do not have a very good understanding, you will not be able to refer them correctly. So, but the IET also published the set of the guideline notes. There are, I think, more than 8 books, those type of guideline notes. So those are very good, very useful, where you can refer them. And also the reference to those guideline notes and the IET wiring regulation, there are a few other the standard textbooks. So even if you can drop me an email, I can give you some guideline. So those standard the textbooks are also there, where you can get a very good understanding. What I'm advising is at least get the guideline notes of the IET. So that will give a very good, including the testing, the commissioning, and the designing, and all those things are there in the guideline notes.
Okay. I think one or two more questions. What is the best earthing system, TT or TN, in bulk supply of 1000 kVA with a standby generator?
As I said, because when you compare these TT earthing and the TN earthing, and if you are getting a bulk supply, as I said, because we are getting a best protection and the best and the coordination, everything in the TN system compared to the TT system. Only advantage in the TT system is where you are having the low cost for your earthing earth connection. So your circuit protective conductors, because you need to have a very low size of protective conductor. Other than that, my judgment is TT is not a very good earthing arrangement, where the best is for TN earthing arrangement. Even when you go with the bulk supply, you can decide whether to run the generator as a TN earthing system, or even if you sometimes in some locations you have to run the standby generator as a emergency standby, where even something happens or you don't want to stop the generator. In that case, even with the TN system, you can run your generator as a IT system. That is also allowed. especially like a data centers and many other special installation, we do design like that. That is allowed. Your normal system, you run it as a TN system, and under the emergency situation, so that you run your emergency supply as a IET system. So where you, even with any other disturbances, you run the system. So that my opinion is, if you have your dedicated transformer, why do you want to run it as a TT? Okay, go for TN.
Yeah, understood. Final question, Dr. Asanka. Is there any sum of equipment leakage current percentage that can be connected to any RCD rated residual current?
Sum of the,
is there any sum of equipment leakage current percentage? I think some problem with the wording. Any sum of
maybe he is asking normally when we look at the different type of equipment, especially like the air condition, and there are
total. He's asking for the total leakage current, sum of equipment leakage current percentage.
Yeah. So sometimes in the building there will be certain leakage current because the theoretically there cannot be any leakage current from any equipment. So if you have a leakage current, it's there should be a certain problem. But as I said, there can be certain type of leakage current, especially like I'm talking about the power frequency. There cannot be power frequency leakage current in any of the equipment. If there is a power frequency leakage current, that means there is a certain problem in the equipment. Nowadays, as I said, there are a lot of power electronic based equipment which are creating certain the leakage current due to the harmonic filtering and the electromagnetic compatibility filters, EMC filter. So normally because of that, that's why when we are selecting these the residual current devices, we allow certain type of percentage, normally something like the 10% or lesser than that. So the compared to that leakage current sensitivity, as a leakage current, that is allowing that, okay, there can be certain type of abnormal the unavoidable leakages in the system. So even, for example, even if you look at the cable also they have a certain insulation level. But when you have an insulation level, that means there is a certain leakage current from the cable itself as well. Likewise, all of them are aggregated, but you can decide. So depending on your cabling system, depending on your what type of equipment are there, even in the equipment, depending on the insulation level, there will be certain leakage current. For example, if you have a 1 mega ohm insulation level, means okay, there is a certain microampere level leakage current from that equipment. You cannot avoid that part because due to the insulation capacitance always there is a leakage current, but you can estimate that part. So as a designer, so the depending on the list of equipment, list of cable and their cable length, you can estimate what is the leakage value, and you can set your helpful detective devices leakage current a little bit higher than that value. So there is no such value saying that, as I said, where the people are generally tend to go for this type of a thumb rule kind of the design. What I'm advising is I don't have thumb rule kind of designs. What I do is, okay, do the correct calculation and then decide the value based on the correct calculation. Don't depend on the thumb rules.
Okay, thank you very much, Dr. Asanka. I feel guilty now for overusing your time and effort. It's been 2.5 hours now, and you answered more than 20 questions after conducting a good, very comprehensive presentation.
Dr. Lalit, I have a final question to get his view. Dr. Asanka, in Korea, each and every circuit, they use the RCBO, each and every circuit. But in Sri Lanka, we use only the MCB. I know the reason, the protection and everything. Why we can't go for that kind of level?
Yes, we can go because that is the best option. Normally, if we can protect all the circuits with the RCBO, then that will give the for protection as well as the overcurrent protection. But the main reason is the cost, because this cost different. But if the client is willing to afford, then the best thing is, okay, if we can convince them, even we can go with the RCBO, so that now even here you can see what I'm telling you is our future consumer box. So this is a unfortunately due to time limitation, I didn't explain this one, but even our the system should be something like that. You can see we have the R4 detection, RCBO, the surge protection, and main isolation. All of them will be your final consumer box. As you correctly said, so this is where we have to go ahead. But unfortunately, as a developing country and it's a low country, so that we are somewhat satisfied with whatever available. But the thing is this. Very true, Ravi.
Yeah. Okay. Thank you. Thank you. Actually, thank you.
Right. Thank you, Ravi, and thank you all the participants who have very enthusiastically engaged with the presentation and the Q&A session, especially SLT, Mr. Gunathonga and our own Ravi. Dr. Asanka, as I said, I feel guilty and for overusing, and it was a very, I'm sure you must be very tired now. We don't have a way to, even appreciate your effort physically, but when the things are normal, we will definitely come back to you. And there was a suggestion even, there were many questions, and you had to give very long answers. And if you agree whether we can have another session to take up all the questions in detail, and we'll see how time permits and your availability. On behalf of IET Sri Lanka Network, I thank you very much for enlightening our engineers and bringing out all the new technological enhancements and new amendments in the 18th edition. So it was a long way from 1882 to 2018, having gone through all the amendments, and now we have a Sri Lanka Electricity Act and regulations also in terms of legality of it. And so we learned a lot. And as I said initially, this is the most exciting and most demanding webinar or evening forum for IET Sri Lanka Network over the years. We had over 75 attendees today. I thank for the survivors until now. And Dr. Asanka, once again, thank you very much for your excellent presentation and excellent way of answering for many questions in very detail. Thank you, my colleagues from IET Sri Lanka Network, executive committee members, and all the IET members and non-members for attending this session. We'll see you in the next webinar or our conference soon. I think in 2 days' time, we have annual technical conference of IET Sri Lanka Network on Saturday. With having said that, I wish all of you pleasant evening and good night, and be safe, everyone. Thank you very much, Dr. Asanka.
Thank you very much. Thank you.
Thank you, Dr. Asanka. Thank you. Thank you, Dr. Lalit. Okay, bye.
Thank you. Thank you so
There
much.
were there were many appreciative notes in the chat box. We will share.
Yes.
Yeah. Thank you very much.
Okay.
Thank you.
Thank you, Dr. Asanka.